name is Sinosh, and today we are going to talk about Docker. So, what is Docker? Docker is an open platform for developers and system admins to build, ship, and run distributed applications. Docker containers are not virtual machines. It does not create an entire operating system like virtual machine, but it uses kernel of host operating system and creates virtualization only for the application and the necessary libraries. Due to this, it makes Docker lightweight than virtual machine. Docker promises build once, run anywhere. You might have faced this situation many times that your code executes perfectly in your local machine but refuses to do so in dev stage and production environment. One of the reasons for this is version of the supporting tools needed by your application to execute mismatches with the one on dev stage or on production environment. Now, in this case of Docker, when an application executes in your local system, you can build an image of your application with the dependent tools, and this same image is used to deploy on dev, stage, and prod environment. These images can be stored in local Artifactory or on your network Artifactory or on Docker provided libraries like github.com or hub.docker.com. You may also download pre-created images from these libraries. Now let's have a comparison between virtual machines and Docker container. So in virtual machines, there is a bottom layer of infrastructure. Now this infrastructure can be your laptop or a dedicated server running in a data center or a virtual private server that you are using in the cloud such as DigitalOcean or in Amazon EC2 instances. Second layer is host OS. It can be Mac OS or Windows or Linux. Then there is hypervisor. It's a self-contained machine packed into a single file, but someone needs to run that file. That's where hypervisor comes in picture. There are two types of hypervisor. One, direct link to infrastructure, example HyperKit or Hyper-V as in Windows. Second is which runs as an app on the host OS, example VirtualBox, VMware or KVM. Hypervisor is like VirtualBox or VMware, which uses computing power of your server to provide a virtual hardware that is then consumed by guest OS, and that guest OS is where you as a developer install all the dependencies for your application. So it's great for isolation, but there is redundant OS as we are running a host OS and a guest OS. Hypervisors are software, firmware, or hardware responsible for creation and execution of virtual machines. Hypervisor available in market are KVM, Red Hat Enterprise Virtualization, Microsoft Hyper-V, Zen Server, and VMware. Next layer is guest OS. Let's say you want to run 3 applications on your server in total isolation. That would require spinning up 3 guest OS, which are all controlled by your hypervisor. They could all be the same guest OS or different. It doesn't matter. Now the problem here is that each guest OS is itself might be 700 MB. So 3 OS will be 2.1 GB plus CPU and memory resources. So there is lots of waste happening here. And also each guest OS needs its own copy of various binaries and libraries for your application to execute. And final layer is our application. Now let's see what Docker container consists of. So as we can see at the bottom there is infrastructure. So it can be your laptop or server in the cloud. Then there is a host OS. This can be Mac OS or Windows or Linux. Then there is Docker daemon or Docker engine. It replaces the hypervisor. It's a service that runs in the background on your host OS and manages everything required to run and interact with Docker containers. Then there is binaries and libraries. Instead of executing them on guest OS, they get built in special package called as Docker images. Then the Docker daemon execute those images. Now these are the same images which we discussed earlier. And the last layer is your application. Now these are also packed in the same images as binaries and libraries. So now we don't need any hypervisor or VM. Instead, Docker daemon communicates directly with host OS and know how to ration resources for the running Docker containers. Now if we compare virtual machines and Docker containers, we can see like virtual machines take a minute to start, whereas Docker containers start in milliseconds. There is wastage of resources in virtual machine, whereas Docker containers save resources. And in virtual machine there is isolated system, whereas in Docker containers there are isolated application. Now let's see a real world example. Imagine you are going on a vacation. So for that you will need a place for rest and basic amenities like bathroom with water and power supply. So in this scenario, you need limited resources in budget, and that is where hotel industry comes in picture. So best solution is to rent a room in a hotel. Here, virtual machine is like having a house with kitchen, bedroom, bathroom, power and water supply and security. And Docker is like a hotel room where you get limited resources and also you can share them and pay for what you use. Docker led the way to the container world, but now there are a variety of other options. Following are 5 solid alternatives to Docker: Open Container Initiative, Kubernetes, CoreOS and Rocket, Apache Mesos and Mesosphere, Canonical and LXD. So this was a basic introduction to Docker. Thank you for watching and see you in the next video.